So in this video, we're going to carry on looking at systematic naming of our organic compounds, but this time we're going to focus more on our haloalkanes, our alcohols, our aldehydes, ketones, and our carboxylic acids as well. Now we're looking at nomenclature again, so we're just naming organic compounds, and we need to follow the same rules as we did before. But first of all, we need to find the longest carbon chain to avoid making any silly mistakes. We then need to label any functional groups or branches that we might have. We need to number the carbon atoms from the point of priority, which is going to be, of course, where we have our branches and functional groups, and then we put it all together in alphabetical order when we're dealing with multiple different prefixes. Now, of course, prefix, stem, suffix is the system we follow. Prefix is the starting bit, the stem shows us how many carbon atoms we've got, that's the middle bit, and then the suffix is going to be the ending point. That's going to be, of course, how we end the actual molecule itself. Now, looking at this first one over here, I need to find the longest carbon chain. In this case, I've got 1, 2, 3 carbon atoms all together. So I know, of course, I've got my longest carbon chain being 3. So I've got 1, 2, 3 carbon atoms. I've got a carbon that's bonded to an oxygen, and then that oxygen is bonded to a hydrogen. So I know over here that I've actually got an alcohol. Now that functional group means that I've got the homologous series of alcohols, so I know in terms of my suffix it's going to end in "ol", but we've got to be very specific over here. But before we actually do that, we're going to actually number our carbon chain, and we're going to say that our point of priority is where the alcohol is, so we need to number it from this side over here. I've got 1, I've got 2, and I've got 3 carbon atoms. Now in terms of my prefix, I don't actually have any, but my stem, I'm going to say I've got prop because I've got 3 carbon atoms. Now what about my suffix? Well, I need to highlight the position of the alcohol. That's at the position 1. So I say I've got propan, and then it's going to be 1, and I'm going to end it in "ol". There's my suffix there, and I've got a very specific example of an alcohol here, which is going to be propan 1O. Looking at the next one, I've got here, of course, a molecule that looks a bit more complicated. We've got multiple different halogens on there as well. The first thing that I need to do is find the longest carbon chain. I've got 1, 2, 3 carbon atoms over here. I need to identify any functional groups and branches. I've got here a bromine to make it a bromoalkane, and then I've got here fluorine to make it a fluoroalkane as well. So this is going to be a haloalkane, and we already know in terms of how we number it from the side where we meet the functional group first, right? If I were to number it, I would go 1, I would go 2, and then I would go 3 over here. And the reason why we actually do that is because the halogen, the first halogen, is going to be at the 1 position rather than the actual other side where we would end up with, if I were to draw that out, 1, 2, 3 again, we would end up with our first halogen being at the 2 position instead. So yeah, what we want is the halogen at a smaller number. Where we meet the halogen first is the side we start actually numbering it. So in that case then, right, I've got over here the positions of my halogens. I've got 1, so I'm going to say I've got 1, and then it's going to be bromo. There's a prefix over there. Over here I've got fluorine at position 2, so I would say I've got 2, and then it's going to be fluoro. There's my 2 prefixes. Now my stem itself, because I've got 3 carbon atoms, is going to be prop. My suffix, my ending, is going to be "ane" because it's a haloalkane. So how would I actually go about putting these in order? Well, I need to think in terms of alphabetical order. I've got B and I've got F. So we know in the alphabet B hopefully comes before F. So in that case, I put 1 bromo first, just because it's going to be in alphabetical order, and we need to get rid of any ambiguous answers. So we end up with 1 bromo, and then it's going to be a hyphen again to separate the letters from the numbers, and then it's going to be 2, and then it's going to be fluoro. And then we just put our stem prop, and then it ends in "ane". So I've got 1 bromo, 2 fluoro, and then it's going to be propane itself. And there's that one done. Again, if you want to try some of these examples, just pause the video and then resume, and then of course mark and check your answer. Looking at the next one, you can see over here, I've got 3 carbon atoms in total. My longest carbon chain is going to be 3. I know, of course, here I've got a carbon double bonded to an oxygen. It's at the end of the chain. So I know, of course, I'm going to be dealing with a functional group for an aldehyde. Now, in terms of aldehydes, we would name it with a suffix ending in -anal, but of course, our stem would be the same as it would normally. A prefix, we don't actually have any in this case. Now, how would I go about numbering this? Well, I would go 1, and then I've got 2, and then I've got 3 carbon atoms in total. So I know, of course, I'm going to have here prop. That's going to be my stem. and then because our aldehyde can only be at the end position, you can't actually get it in the middle. That will change it to a ketone. We just put prop. We don't need to highlight the position. We just put prop, and then it's going to be ano. So there's our aldehyde named. Look at the next one. We've got here a ketone. How do I know it's a ketone? Well, I've got a carbon-oxygen double bond that's not going to be at the end. So in other words, it's going to be in the middle of the carbon chain. It could have been at this carbon here. It could have been at this carbon here, and it still would have been a ketone itself. But remember, ketones in most cases, you can actually have variable positions. So you have to highlight the actual number, the carbon number for it as well. So yeah, we look at our longest carbon chain, follow our rules again. We've got 1, 2, 3, 4, 5 carbon atoms. And then we need to think, okay, 5 carbon atoms, that means pent. So which way do I actually go about numbering it? Well, in this case, because the ketone is in the middle, doesn't really matter which way you go about numbering it, because either way, you will end up with the ketone being at the 3 position itself. So yeah, if I were to look at this, how would I name it? Well, I've got ketone. It's going to be at the 3 position. So my suffix changes now. My stem is going to be, of course, pent, because I've got 5 carbon atoms. And then my suffix is going to be an, and then it's going to end in 3, and then it's going to be on itself, and that's how we name ketones. So yeah, moving on, some more examples over here. I've got a mixture of different functional groups now. That's going to be on, of course, our organic molecules, and we need to follow the rules again. Now, starting off with the first one, we need to find the longest carbon chain. In this case, I've got 1, 2, 3 carbon atoms in total altogether over here. So my longest carbon chain is going to be 3. We can see in terms of our functional groups, we've actually got an alcohol over here. We've got a bromine atom there, bromine atom here, and another bromine atom over here. Now, in terms of numbering it, the alcohol, because it's slap bang in the middle, it's on the second carbon atom, that doesn't matter too much. So that's when we start to look at the actual bromine atoms. We would start to number it from left to right. So we end up with 1, 2, 3 carbon atoms labeled in this way itself. Now, of course, you can reflect this molecule, and you would have to name it from right to left, but in this case, right, we would go from left to right. Just be aware of that the examiner could actually give you the molecule in a different way, but as long as the name is the same, it fits the name, then it's going to be right. Now, if we were to go about naming this, we can see, of course, our prefix. That's the bit we start with. That's going to be, of course, bromo, but we've got 3 of them, so we would say we've got tri-bromo. Remember, if you've got 3 branches or 3 groups, you would put tri. If you've got 2, you put di. 4, you put tetra. If I were to look at this, I need to highlight the position of each one of them. So I've got 1, 1, 1, and then it's going to be hyphen, and then it's going to be tri, and then it's going to be bromo. That's our prefix done. What about our stem? Well, we've got 3 carbon atoms, so in that case we would have prop, but then we've got an alcohol at position 2, so we would have prop, and then it's going to be an 2, and then it's going to end in all itself. And there's the next one named there. Look at the next one. Next one's a bit trickier. You've got here a carboxylic acid and then some halogens on there as well. Follow the rules as before. We've got the longest carbon chain. It's going to be, of course, carbon 1, 2, 3, 4 carbon atoms. It's going to be bute for our stem. Now, in terms of our functional groups over here, I've got a carbon oxygen double bond, but of course, because I've got that OH attached to that carbon, I know it's going to be a carboxylic acid. Now, in some cases, you might actually see it more often, to be honest, like this, where it looks something like this. That's what a carboxylic acid looks like, and you need to be able to recognize that that's different to an aldehyde, because rather than having hydrogen here, you've actually got an OH there. Now, this carboxylic acid functional group always comes at the end, because you can't actually have, right, 1, 2, 3 bonds, and then you can't actually have a 5th bond, right, to continue the actual chain. That's why it always appears at the end, and it will always take priority. Normally, your carboxylic acid takes the highest priority, then comes your aldehydes, your ketones, and then, of course, your alcohols, alkenes, and then it's going to be your halogens, and then your branches itself. So yeah, we've got here some other functional groups as well. I've got iodine, I've got fluorine. How do I go about numbering this? Well, I've got carbon atom 1, 2, 3, 4 over here. So in that case, I know in terms of my stem, it's going to be bute. In terms of the suffix, it's going to be butanoic, space, and then acid. But then what about these iodos and fluoros? Well, in terms of the positions, they're at position 2 and position 3. So in that case, I would end up with, in alphabetical order, F comes before I, hopefully, I end up with 2, and then it's going to be hyphen fluoro. And then it's going to be hyphen again to separate the numbers from letters, and then it's going to be 3 iodo, and then we end up with, of course, our stem, which is going to be bute, and then we say anoic, and then we put a space, and then we put acid. Now we never need to highlight the actual position of the acid because it's always going to be at the end. It's always at position 1. So in that case, there is our correct answer. That's how we go about naming that. So yeah, looking at the next one then, we've got here some trickier examples again. You've got here 1, 2, 3, 4, 5 carbon atoms all together. You know it's going to be, of course, a carboxylic acid on this side, but we've also got an alcohol over here. Now this is where it gets a bit tricky, because if you were to have an alcohol and you were to have something of higher priority like a carboxylic acid, what that would mean is that the alcohol would change to its prefix form. So instead of saying ol, you would say at the start as a prefix, you'd say hydroxy instead. Now if I were to number this, I've got 5 carbon atoms. I would number it from, of course, the carboxylic acid, and here we would actually call this pentanoic acid, but our prefix, because we've got an alcohol at the 5 position, we would say we've got 5, and then it's going to be hydroxy, and then it's going to be pentanoic acid itself. So in that case, I end up with 5 hydroxy pentanoic acid, and there's that one done. The next one is a bit trickier. Again, we need to find the longest carbon chain, which is not going to be, of course, 3. It's going to be, of course, 4 instead, where I've got carbon 1, 2, 3, 4 over here, and then I need to think about my branches, my functional groups. I've got here a methyl group over here, I've got an alcohol there, and then I've also got a chlorine here and a chlorine here as well. Now if I were to think about this, right, I need to think about which way I need to number this. I would number it from right to left over here, because I've got an alcohol and a halogen on carbon 1, and then on carbon, let's see, if I went from left to right, if I went 1, 2, 3, 4 this way, I would not actually have anything on carbon 1. So in that case, we actually end up going from right to left over here compared to left to right, because we actually see the groups of priority, which is either the alcohol or the chlorine. Doesn't matter what it is in this case, we see it on carbon 1 compared to left to right, where we see it on carbon 2 instead. So yeah, I'm going to go with the top method in this case. So what I end up with for my stem, it's going to be bute, but my prefixes is where it starts to get a bit more complicated over here, because on the actual 3 position, we've got our methyl group, we've got a branch there, so we say we've got 3 methyl. In terms of our halogens, we've got 1 and 2, so in that case, we would have 1, 2, and then it's going to be hyphen, and then it's going to be dichloro, not just chloro on its own. How would I actually put these in order? Well, my prefixes here, I've got M over here, I've got C over here. If I were to put in alphabetical order, I would end up with 1, 2 dichloro, because there's a C there. Remember, we don't look at the di. And then we would end up with hyphen, and it's going to be 3 methyl, and then we would name the rest of the molecule. Now this one's quite a tricky one, because you've actually got 2 alcohols at position 1, and then you've got 1 at position 3 itself. So then what you would need to put is, of course, your stem, which is going to be bute, and then of course to name alcohols, it's very similar to alkenes in this case. You would put butane, and then it's going to be, of course, hyphen 1 and then 3, and because you've got 2 alcohols there, you would say di. So just like dimethyl, just like dichloro, you would put di, and then it's going to be ol itself. And there's that tricky example there done. Now, of course, in some cases, you can actually get away with saying buta 1,3-diol, but of course, I prefer butane 1,3-diol itself as well. Now, of course, I've got a task for you to do. Feel free to pause the video, have a go at naming the following molecules, and resume once you're ready to go over the answer. So yeah, looking at this first one over here, we can clearly see that the longest carbon chain is going to be, of course, 1 carbon atom. So in that case, we know our stem is going to be meth, and our suffix is going to be in, so in that case we know it's going to be methane. Now in terms of our halogens, I've got a bromine there, so bromo, fluorine there, so it's going to be fluoro, I've got iodine there, so it's going to be iodo, and I've got chlorine there, so it's going to be chloro. Now if I were to look at this in terms of alphabetical order, the bromine is going to come first, because B comes first before C, F and I. Then my chlorine is going to be next in terms of my prefix, and then my fluorine is going to be next after that, and then my iodine is going to be after that as well. So yeah, if I were to name this molecule, right, quite nasty looking, but of course it's still possible. I would not need to highlight the position, because there's only 1 position. So I would say I've got bromo, and then I've got, of course, chloro, and then I've got fluoro, and then I've got iodo, and then it's going to be methane. And there's that first one done. Look at B, right? Longest carbon chain over here is going to be, of course, 4 carbon atoms. I've got here 1, 2, 3, 4 carbon atoms, again, going in any direction. And then I've got to think about what groups I've got. Got a methyl there, got a chlorine there. Which way would I go about numbering it? Well, of course, if I went this way, let's say in the light blue way, I've got 1, 2, 3, 4 carbon atoms there. If I went in the purple way over here, you can compare the differences. The halogen, remember, it takes priority over the methyl group. So in that case, we actually prefer the light blue way, because in terms of the light blue way, you end up with the chlorine at the 2 position. Whereas if you went about it the purple way, the chlorine will actually come at the 3 position instead. So we want the light blue method. So we've got the chlorine at the 2 position and the methyl group is at the 3 position. Remember, the chlorine, the halogen, is going to take priority over your branches. So in that case, our prefix is going to go in alphabetical order as well, because we've got here methyl, that's an M. We've got chlorine, which is a C. So in that case, I end up with 2, and then it's going to be chloro, because hopefully C comes before M. And then we end up with hyphen, and then it's going to be 3, and then it's going to be methyl itself. So I end up with 2 chloro, 3 methyl, and then it's going to be, of course, butane in this case for 4 carbon atoms. Look at the next one. I've got here 5 carbon atoms. My longest carbon chain is going to be 1, 2, 3, 4, 5. I know in terms of functional groups, I've got a ketone over here. I've got a halogen over here as well. Now, if I were to number it, I would end up with having 1, 2, 3, 4, 5 carbon atoms over here. I wouldn't actually go about it from left to right in this case, because we've got a bromine here. The ketone doesn't really matter, although that would take priority, because that is going to be slap bang in the middle. It's going to be on the 3rd carbon, even if we went from left to right. So in that case, how would I name that? Well, I've got here 1, and then it's going to be bromo. And then it's going to be, of course, our ketone. It's going to have 5 carbon atoms, pentan, and then it's going to be, in this case, 3 on as well. Remember, you can also end up with pentan 2 on, so you'd need to highlight the position of that. So yeah, there's that one done as well. Look at the next one. We've got our longest carbon chain being 1, 2, 3, 4 carbon atoms all together. We can see here in terms of functional groups, we've got a carboxylic acid there, chlorine there, methyl group there, and then we've got an alcohol over here as well. Now, in terms of our stem, it's just going to be, of course, bute. In terms of our suffix, it's going to be anoic acid. Remember, the alcohol now is going to become hydroxy. Our chlorine is going to be chloro, and our methyl is just methyl, isn't it? We've got 1, 2, 3, 4 carbon atoms if we number it this way. And so we would say we've got, in order, we're going to have first of all the chlorine that comes first, because of course we need to go in alphabetical order. So yeah, there's our chlorine at the 2 position, and then of course we've got our hydroxy, which is going to be at the 3 position, because remember, H comes before M itself. So I end up with 3 hydroxy, and then I'm going to end up with another hyphen, and then it's going to be 3 methyl itself. So yeah, how would we name the rest of this? Well, we've got 4 carbon atoms, so I'd say I've got butanoic, because it's a carboxylic acid, and then it's going to be acid itself. And there's that tricky example there done. So moving on then, what about drawing the displayed formula of all of these structures? Well, displayed formula, remember, is the formula showing the relative positioning of all of our atoms in a molecule and all of the bonds between them as well. Now remember, carbon usually has about 4 bonds, hydrogen usually has about 1, and then oxygen again 2, and then nitrogen 3. The reason why I say usually is, of course, you can end up with, in some cases, more or less than the actual amount that I've shown here. But again, that's for another day. Now, if we were to look at the following, we need to draw the structures of the following molecules. And again, I would start off by looking at the stem. It's going to be bute. So I know I'm going to have 1, 2, 3, 4 carbon atoms in total. Now, of course, I've got a chlorine at the 3 position. So if I were to number this, I've got 3 carbon atoms over here. So at the 3 position, we've got a chlorine, and then we've got an alkene at position 1 as well. So I'm going to have a double bond over here. Now, I just need to make sure that I've got all of my carbon atoms with 4 bonds. So I've got all of my hydrogens on there as well. And then, of course, remember, you need to make sure you've got 4 bonds. So you need to do these ones as well. And don't forget, when it comes to, of course, your alkene, you're going to have 2 bonds on this carbon atom and this carbon atom over here. So don't add an extra hydrogen itself. So yeah, there's that one done. What about the next one? Well, we've got here 2,3-diiodo. So we've got 2 iodines on there, and then butan, and then it's going to be 1O. So again, I'm going to have 4 carbon atoms, 1, 2, 3, 4 carbon atoms, and then I'm going to number them as well, just to make my life a lot easier. On the 1 position, I'm going to have an OH, but remember, because it's displayed formula, you need to show, of course, the oxygen bonded to the hydrogen like this. You can't actually do something like this if it asks for displayed formula. Just be aware when it comes to structures, a lot of people tend to put this as well. That's going to be wrong. If you were to just draw the normal structure, the oxygen needs to be bonding directly to the carbon atoms itself. So this one is going to be correct, that one's going to be wrong. Now let's say if the OH was on sideways, you could actually end up with OH over here like this, which is actually going to be wrong itself. Instead, you will need to show the bond going directly to the actual oxygen itself, so you end up with something that looks like this itself. So yeah, coming back to our example then, we've got an iodine at position 2, an iodine at position 3, and then we go ahead and we add in our remaining hydrogen atoms. So in this case, you can see I've got all of my hydrogen atoms being added on, making sure that I've got 4 bonds to every single carbon atom, and remember oxygen needs to have 2 as well. Right, so moving on, I've got a task for you to try. Feel free again to pause the video, have a go at the following questions, and then resume once you're ready to go over the answer. So you're looking at this one over here. I've got prop. I'm going to end up with, of course, 3 carbon atoms, and I'm going to end up with something that looks like this. I'm going to number them as well, and I'm going to number it in this direction, but of course you can do it in any. You could have gone 3, 2, 1 as well. Now I'm going to go with, of course, my aldehyde. That's going to be at position 1. So I'm going to end up with a carbon oxygen double bond that looks like this, and then I'm going to end up with a hydrogen that's going to be over here as well. Remember that carbon atom needs to be at the end with the oxygen double bonded to it. So you'd have a hydrogen there too. There's the aldehyde functional group done. And then we've got 2,2 dibromo. So I've got 2 bromines at the 2 position over here. So I end up with 1 there, 1 here. And then I just need to make sure I've got hydrogens added for the remaining bonds itself. And there's that one done. Look at the next one. We've got pentan 2-ol, 3-methyl pentan 2-ol. So we know, of course, we've got 5 carbon atoms in total, 1, 2, 3, 4, and then 5. I've got positions as well, 1, 2, 3, 4, 5. And then on the 2 position, I'm going to have an oxygen bonded to, of course, a hydrogen. I'm going to end up with, of course, in the 3 position, a methyl group, which is going to be quite hard to draw, but I'm going to draw it like this anyway. And then I'm going to end up with, of course, my actual remaining hydrogen atoms to make sure I've got 4 bonds to actual every carbon atom. So I end up with something that looks like this. I've got a few more left. Takes up quite a while, but of course always prefer skeletal. And there's that one done. Looking at the next one, I've got here prop for my carbon atoms. So I've got 3 carbon atoms in total. Now I'm going to number this one just for the sake of it to show you a reflected image. I've got 3 carbon atoms over here, and I'm going to say the carboxylic acid part, the anoic acid part, is going to be at the end over here. I end up with oxygen bonded to the hydrogen there, and then on the 2nd position I end up with my alcohol, which looks like this. Again, we're practicing using displayed formula over here rather than just a structure. So in that case, I end up with hydrogen over here as well. Don't forget your carboxylic acid. That carbon here needs to have 4 bonds as it does. But of course, I'm going to get rid of this number here now because it kind of looks like another bond itself. And I'm going to put it over here at the bottom instead. So I've got 1, 2, and then 3 carbon atoms all together. So yeah, there's that one done. We're about the last one. This one, it's not that tricky. If you break it down, you've got the stem, you've got 1, 2, 3, 4 carbon atoms. And then of course, if I were to number it, I've got 1, 2, 3, 4 going from left to right in this case. And I'm going to end up with a chlorine at position 1. I'm going to end up with a methyl at position 2. So I end up with C. And then I'm going to have to draw it smaller over here because it's quite squished. I've got the H's there. And then I've got an alcohol at position 2 as well. So on the other side, I'm going to have oxygen bonded to hydrogen. And then I'm going to add my remaining hydrogen atoms on there as well. So I end up with a structure that's going to look like this itself. So I end up with 1 chloro, 2 methyl, and then it's going to be butan 2-ol. Now I'm going to get rid of my numbers over here because it's starting to look quite messy, but I'm going to end up with, of course, my hydrogen final one that's going to be here as well. And there's that one done.